This meeting is being recorded.
In section 12.7, it begins by asking us to consider the reactions shown here below. So we have this species here that we're considering turning into a Grignard reagent. So this will be a hypothetical Grignard reagent because we know that Grignard reagents, right, this carbon here would act as a carbon ion, which can be very basic, and it cannot be in the presence of an acidic proton. So we know that alcohols can function as an acid. So Grignard reagents and alcohols are therefore incompatible. So we cannot make a Grignard reagent out of this alcohol. If we want to form this specific product, we would have to use something called a protecting group. So we could protect this alcohol group here. So we protect the alcohol. We could then perform our Grignard reaction in step 2. And then, so that involves forming the Grignard reagent, reacting with the compound, forming your alcohol, right? So all these individual things happen in the Grignard reaction. And then we still have our protecting group here on our alcohol product. We've seen we've added our R groups here as well. And now we want to deprotect our alcohol functional group. So certain reagents will be used in that step. So let's see what type of protecting reagents we could use. We have something called a trimethylsilyl group that could be used, TMS for short. And we see that here. We have our silicon atom surrounded by 3 methyl groups, hence the name. And we've added this trimethyl silyl ether, TMS, and the oxygen here to our, or I'm sorry, we added the TMS to that oxygen rather. So we've created this functional group here on the end of our original alkyl halide alcohol. So now that we've protected this portion, we should note that we need to have this occur in the presence of a base because trimethyl silyl chloride, when the chlorine is expelled in this process of protection, right? This is the original structure here. That's a leaving group. And then we have this protected alcohol now, functional group, we would produce HCl. So we use this strong base here, this triethylamine, to grab that proton and not form HCl. So that's what's meant by this triethylamine is used commonly. The presence of base is initiated to grab that proton. So the mechanism that we see suggests a substitution of the silicon atom occurs by an SN2 mechanism. But this trimethyl silyl chloride here, this actually, or rather, this is tert butyl chloride, and then our TMS chloride over here. This is not as, it's a tertiary structure, right? That silicon is bonded to 3 methyl groups, a tertiary silyl halide, if you will, right? Because we have a tertiary alkyl halide here that we cannot perform a substitution reaction, an SN2 mechanism specifically with. But because the silicon atom is that much larger than our carbon in our tert butyl chloride, it can be attacked. It's not sterically hindered. So that's why we can use this TMS chloride, but we could not use tertiary reagents in a SN2 mechanism previously from chapter 7. So now we're ready to deprotect. So we have our TMS group here on our finished product. We want to remove this. It can be done either with acid or with fluoride ions. And we're showing that this TBAF acronym here is commonly used to supply the fluoride ions. And the acronym stands for this tetrabutyl ammonium fluoride compound. And we can see everything kind of all pulled together here in this last slide. So we had that starting alkyl halide that also had that hydroxyl group. So we protected it using our TMS chloride in triethylamine as our base. So we didn't produce that HCl. So now we are protected after that first step. And then we form our Grignard reagent. So we would add magnesium in step one. That would kind of sandwich itself right here. And then we can perform our Grignard reaction. So we have our carbonyl, we have our water as our proton source, and then we produce this structure here when that alcohol group is still protected. So now we can use the reagent TBAF in this last step to deprotect our other alcohol functional group. So this is the overall summary of how to protect an alcohol group, then how to perform a reaction with a Grignard reagent and form our final product after deprotection.